Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph two rational functions using our 7-step process. So basically, when we're going to go through this, we want to go ahead and first determine our symmetry. So I'll kind of go through this as quickly as I can here. So I'll plug in f of negative x. When I plug in negative x, if I obtain the exact same function back out, then I know that I have symmetry about the y-axis. If I obtain the negation, then I have symmetry about the origin. So negative x raised to the positive fourth, whenever you're raising to an even power, it's going to become positive. So that becomes 2x to the fourth over negative x squared is positive x squared plus 1. So you can see when we evaluate for negative x, we get the exact same function up. So we can say this is symmetrical about the y-axis. So that's very important. So whatever points we figure out on the left side of the y-axis, we can reflect them over on the right side. So that's symmetry. Next step is we're going to want to determine the x and the y-intercept. So to do that, to determine the y-intercept, you just plug 0 in for x. So I have f of x equals 2 times 0 raised to the fourth over 0 squared plus 1. Well, 2 times 0 is going to be 0. Over 0 plus 1 is 1. So therefore, that equals 0. So I'll write the y-intercept at y equals 0. Step number 3, vertical or x-intercept. So on the x-intercept, you put 0 in for y. So f of x represents our y. So I'm going to do 0 equals 2x to the fourth over x squared plus 1. Again, to get rid of our denominator, I'm going to multiply by the reciprocal. That goes to 0. That goes to 1. I'm left with 0 equals 2x to the fourth. When you go ahead and solve, I'm not going to go through the inverse operations. You divide by 2 on both sides. You get 0 equals x to the fourth. You take the fourth root on both sides, and you get x equals 0. OK. And the reason why I'm not doing that is I'm just trying to move forward a little bit for these graphs. Step number 4 is determine the vertical asymptotes. So to determine the vertical asymptotes, we basically take our denominator, and we set it equal to 0. OK, now we use inverse operations. And what we obtain here, when I subtract the 1 on both sides, I'm left with x squared equals negative 1. I guess I'll just show you there. Then take the square root. But we have a problem. We're taking the square root of a negative number, which is going to provide a complex solution. Well, you can't graph complex asymptotes, right? So therefore, we can say that there are no vertical asymptotes. Or I'll just write in none. Then we determine our horizontal asymptotes. To determine our horizontal asymptotes, again, we compared the degrees of our numerator and our denominator. So I have 4 is greater than 2. If you look at your horizontal asymptote test, when you have the degree in the numerator is larger than the degree in the denominator, you do not have a horizontal asymptote. So we'll write none. Now, I'll be specific on when we're going to do videos for slant and oblique asymptotes, but I am avoiding them for this video. We just want to focus on rational functions and horizontal asymptotes. But you should always check to see if there is a horizontal asymptote by using division, which if you haven't got to that point, we'll get to it in other videos. So therefore, we don't have a horizontal asymptote. We don't have a vertical asymptote. And the only thing we have is the x and the y-axis. All right? So, but we do know it's symmetry, right? We do know that it's symmetric about the y-axis. So basically, what I'm going to do is I'm going to pick 2 points to the left of the y-axis. And then whatever those points are, I'll determine my graph, and then I'll reflect them over. So let's pick negative 2 or negative 1 and negative 2. So I want to figure out what negative 1 is, and I want to figure out what negative 2 is. So negative 1. Negative 1 to the fourth power is positive 1. 2 times positive 1 is 2. Negative 1 squared is positive 1. 1 plus 1 is 2. Now let's do negative 2. Negative 2 to the fourth power is negative 2 times negative 2 is 4 times negative 2 is 8 times negative 2 is 16. 16 times 2 is 32. And again, that's a positive 32. Negative 2 squared is 4 plus 1 is 5. That's going to be 6.4. Yes, I believe so. 32 divided by 5, 6.4. So instead of trying to graph 32 divided by 5, I'll just convert that to a fraction, which is 6.4. All right, so now at f of negative 1, I have 1. At f of negative 2, I have 6.4. 1, 2, 3, 4, 5, 6. So remember, here's kind of basically my 3 points here. So this graph is going to continue. And then you can see basically it's a parabola. What I'll do is just convert these points over. And then to kind of do the shape of the graph here, you can see I basically have a parabola in this case. All right, so let's get into the next example. Again, we're going to follow through again with the same steps. Step number 1 is identifying symmetry. So I have f of negative x equals negative x squared, or negative x squared minus 4 times negative x plus 3 divided by negative x. That's kind of difficult to do that. So let's go and determine what x plus 1 squared is again. So remember, x plus 1 squared, I'll do this over here because I have some room. X plus 1 squared is equal to x plus 1 times x plus 1. So I can apply FOIL here and multiply this to give me x squared plus x plus 1, which equals x squared plus 2x plus 1. I was going to do that later, but I guess it's important. I guess we can do it now as well. So basically, I could also rewrite this as x squared minus 4x plus 3 over the expanded form of this, which is x squared plus 2x plus 1. And this has become important anyways. I'll explain here in a second and in our future ones. But to do symmetry, it's pretty much necessary. I think it's easier to do that with negative x. So I'll do negative x squared plus 2 times negative x plus 1. OK, so what we get here is positive x squared positive 4x plus 3 divided by positive x squared minus 2x plus 1. Well, you can see that this is not the exact same function, nor is it a negation of every single value. So there's actually no symmetry. So we really didn't need to do that. Well, it's helpful, but it was not necessary. OK. So to go ahead and now the next thing is determine the y-intercept. Remember, x equals 0. Now, again, you could use either one of these values. It doesn't really matter. I'm going to use this one because it's simplified, or it's condensed. So I have f of x equals 0 squared minus 4 times 0 plus 3 all over 0 plus 1 squared. Well, 0 squared is 0. Minus 4 times 0 is 0. So I have plus 3 divided by 1 squared. So therefore, I have my y-intercept. Y-intercept is at 3. All right, so let's go ahead and check the x-intercept. X-intercept is when now y equals 0, or our f of x value. So I'll set that equal to 0. And I have x squared minus 4x plus 3 divided by x plus 1 squared. Again, multiplied by the denominator. And what I obtain is 0 equals x squared minus 4x plus 3. Interesting here, right? So now it looks like I'm going to have two x-intercepts. So I have to use this by factoring. So when I go ahead and factor, what two numbers multiply to give you 3, add to give you negative 4? Well, those two values are going to be x minus 3 times x plus 4. But when I apply the 0 product property and I solve, I get x equals positive 3 and x equals negative 4. OK, I'm just trying to save a little space here. Step number 4 here is now going to determine the vertical asymptote. So to determine the vertical asymptote, we're going to take our denominator set equal to 0. You could use the condensed form or the expanded form. Doesn't really matter. So I'll do x plus 1 squared equals 0. So to go ahead and solve this, I'll take the square root of both sides to undo the squaring. And what I'm left with is x plus 1 is equal to 0. So therefore, I can say my vertical asymptote, when I subtract 1, is x equals negative 1. Step 5 is the horizontal asymptote. And this is why I wanted to expand it. Because remember, the horizontal asymptote is always about the degree of your numerator and denominator. It might not be apparent what the degree is of your denominator when it's not in an expanded form. Because one mistake students make is they just look at the degree of your variable. But remember, this isn't expanded. So when I expand it, you can see that they actually have exactly the same degree. So when you have the degrees that are exactly the same, you now look at their leading coefficients and write an equation. So y equals a over b. Well, in this case, their a over b is y equals 1 over 1, which equals 1. So y equals 1 is my horizontal asymptote. So now let's get to the graphing. OK, so we don't have any symmetry, but we have a y-intercept at 3. We have an x-intercept at, oh, shoot. What am I doing? How did I get that? That's so wrong. It's -1 and -3 and -1. So that becomes a +1. I don't know what the heck I was thinking. OK, so I have x-intercepts at 1 and 3. Vertical asymptote is at -1. And horizontal asymptote is at +1. OK, so let's go ahead and graph. Again, basically what I'm going to do is want to choose two values. Choose values to 2 to the left of the asymptote and then 2 to the right. So my two values that I'm going to choose here, let's see here. I'm definitely going to want to find the value for f of, say, -1, -2, -3. So f of -2, f of -3. This stuff really isn't so obvious. So I'm going to definitely want to choose 1, 2. So definitely choose f of 2. And let's choose 1, 2, 3, 4. Let's do f of 4. All right, so let's see where that kind of gets us here and see if we can plot the graph from there. So let's plug in -2. And when I plug in -2, I'm going to plug it in up here because I think that will be a little bit easier. So I have -2 squared is +4. -4 times -2 is also +4. So I have +4 plus +4, which is 8 plus 3 is 11. And then I have -2 plus 1 is going to be a -1. -1 squared is a +1. So I'm left with 11. At -3, I do -3 squared, which is 9. -4 times -3 is a +12. So I have 9 plus 12 is 21. Plus 3 is 24. Then I have -3 plus 1 is -2. -2 squared is +4. Is 6. So at -2, I'm at 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. At -3, I'm at 6. 1, 2, 3. OK, so you can see here that's kind of taking that shape. Let's go and check 2. So 2 is going to be 2 squared, which is 4, minus 4 times 2, which is -8. So 4 minus 8 would be -4, plus 3 is -1. And then plug in a 2 here. 2 plus 1 is 3. 3 squared is 9. OK. And then let's go ahead and check 4. So at 4, we do 4 squared is 16. Minus 4 times 4 is 0, plus 3. And then I have 3 plus 1 is 4. 4 squared is 16. OK, so I'm going to check the decimal of that. 3 divided by 16 is 0.18. All right, so these two are easy. But at f of 2, I'm at -1/9, which is like right there. And then at f of 4, I'm at 0.18, which is above. So remember, these graphs, remember, they have to approach the asymptotes. All right? It can cross horizontal asymptotes. But I need this graph to approach this vertical asymptote as well as approach this asymptote. So it looks like to me, I can draw the graph approaching here. It's going to have to cross here. It's going to bend down, cross back over, and then start approaching that asymptote. Kind of a funky little graph, but that's the way that it works. So there you go, ladies and gentlemen. That is how you graph your rational functions. Thanks.